So I want to start with some basic definitions and then look at a few examples that show how these definitions really work. Okay, so polynomials are functions that are sums of non-negative integer powers of the variables. This sounds complicated, but it's actually not too bad. Okay, it's things like x to some power that's not negative, and then things like that added together. Okay, so for example, several different ways of writing polynomials appear down here. We have things like y equals x squared. Here the power of x is 2. I also have things like x minus 1. Right? X is a power of x, and then 1 is also a power of x. The power is 0. And here I have many other examples of this. So an important definition related to polynomials is what's called the degree of the polynomial. Okay? This tells us a lot of important information about them. And it's just the highest power of x that appears. In many important ways, that tells the whole story of the polynomial. That's its most important quality, so we give it a special name. So if we look back at some of the examples we have, we can check what the degree is. So for this one, the degree is 2. Over here, maybe it's not quite as explicit, but x is the same as x to the 1. So the degree is 1. Over here, we see a 2 is the highest power, so this is degree 2. For this one here, the highest power is again 2. And then over here, we have a higher order polynomial. We have a 6 here, so its degree is 6. Okay? We will focus on degree 1 and degree 2 polynomials in this course. The reason we do this is that we have a sort of a rich and complete theory for what's going on there. For higher order polynomials, it is still possible to do mathematics, but it gets more complicated as the power goes up. In particular, once you get past degree 5, it becomes very difficult to do certain things. So I'll say that this polynomial here is hard to handle. At least with just kind of pen and paper mathematics. If you're willing to use a computer, you can still do lots of important things. So let's look at just an example of computing degrees. So here I've written out several polynomials, and we just want to quickly assess what is the degree of the polynomial. So all we have to do is check what is the highest power appearing. So I start with this one. My powers are 2, 1, and 0, right? So just recall that x to the 1 is equal to x. So if you ever just see an x by itself, that's degree 1. I should say this is equal to x. And then x to the 0 is just equal to 1. So we say that constants are degree 0. So the highest power here is 2, so we say it's degree 2. We play the same game here, 4, 2, 0. What's the biggest of those? It's 4, so I get 4. Here I'm trying to just trick you a little bit. I have 2, 4, and 0. So even though this one is first, this one is the bigger power, so it tells the story. So we're degree 4. And then here I have sort of another tricky example. Just the number 3. Is that a polynomial at all? Well, there's no power of x. Well, there actually is. It's implicit, right? 3 is equal to 3 times x to the 0. Okay, so that means that this is degree 0. Okay, so an important remark here is that constants are degree 0 polynomials. So this is just one way you might get kind of tricked, is not seeing a power of x explicitly. It can still be a polynomial if it's constant.